Hello guys, and welcome to another video. So in this video we'll be answering a set of Newton's laws questions. Starting with this one, it's a multiple choice question. It says a box of 2.5 kg is being pulled with a force of 25 newtons at an angle of 30 degrees to the horizontal as shown in the diagram below. They ask us what is the normal force, and what you'll remember guys is that if we have our object being pulled at a force that is parallel to the surface, then the normal force is equal to Fg or mg. And then if we have our object being pulled at an angle as this one here, in fact, let's just use the diagram that we have there. Yes. Yeah, so for this one guys, we will just allow me to change. Yeah, if we have our object being pulled at an angle like that, that means the normal force will be equal to N is equal to Fg minus F sine theta. Okay, so that's what our normal force will be like in terms of formula. Now what we are going to do is to substitute it to this formula. Let me just write it here. We'll have N is equal to, where we see Fg, we must now put mg minus F sine theta, and then m obviously stands for the mass of the object, which is 2.5, and the g is the gravitational acceleration of 9.8, and then minus the F is this force, the applied force, which is 25. Then sine, what is our angle? Our angle is 30 degrees, and then we'll get our answer of this from a calculator. When we go to our calculator guys, we'll say 2.5 multiplied by 9.8 minus 25 sine 30 degrees, and the value we get is 12, as you can see. So let's see which answer we have. So this means our answer is going to be what? It's going to be C. Our answer is going to be C, because we are getting 12 newtons. So that's how you treat this question guys. Let's move on to the next one. Okay, for this one they say a force of 300 newtons acts downwards on a 30 kg block at 40 degrees to the horizontal as shown in the diagram below. The block accelerates to the right along a rough horizontal surface. Then 18.1 says calculate the magnitude and direction of the component of the 300 Newton force that accelerates the block horizontally. So we are looking for what here? We are looking for the component force. We're looking for the component force of this particular force here, the applied force. So how are we gonna get our component force? Well, we'll remember that if we are looking for the component force, and that component force obviously is the one that's getting this object to move horizontally. Okay, so it's that one that I'm drawing. Maybe I should change my color. Okay, let's just go back and draw our component force. So this red line here is our component force. Okay, and we can see that it is actually a pushing force. It's pushing this block. To which direction? To the right. So what we are going to do then is to find that component force by saying, since it's the x component, we'll say Fx is equal to this force, which is F, and we'll have cos 40 degrees, and then we'll substitute. Where we see F, we put 300 because F is equal to 300. Then we'll have cos 40 degrees. Then from there we'll go to the calculator. So we'll say 300 cos 40. Let's go to the, so on the calculator we'll have 300, and then we'll say cos 40, and the answer we are getting is 229.81. that is our answer. So our answer here, guys, is going to be 229.81 newtons. All right, we are done with finding that force. Now we can look at the other question. Now the other question here, guys, says if the acceleration of the block is 2 meters per second, calculate the magnitude of the frictional force acting on the block. So here the first thing that we will notice is that the formula for 18.2 will be F net is equal to MA, and then from there F net we know means all the forces acting on our block. How many forces are acting on our block? It's 2 forces actually, the ones that are getting the object to move. It's the component force, which we found, this force here, which we found to be 229.81, and we also have the force of friction. The force of friction obviously acts in the opposite direction. So that means here we are gonna say we have Fx minus Ff. This is the component force minus the force of friction. All of this will be equal to MA. And then our Fx is what? It's 229.81 minus the force of friction. We do not know it. Is equal to, what is our M for this block? I forgot it. It's 30. So the block has a mass of 30, and our acceleration is what? According to this, our acceleration is 2. So what we'll have is negative F, small f, is equal to this value here is 60. When you take this one to the other side, it becomes negative 229.81, and then we divide by the coefficient of F on both sides, which is -1, and then we'll go to the calculator. So what we are going to have is 60 minus 229.81 divided by -1, and the value we are getting is 169.81. so that is our force of friction. That is our force of friction. Therefore friction is equal to 169.81 newtons. Remember, guys, that without the unit your answer is going to be wrong, so please always include the unit. Now let's look at the last question. The last question here says calculate the vertical force exerted by the block on the plane. If they say we must find the vertical force, guys, they're actually saying to us find the normal force. Okay, that's what they are saying, find the normal force. How do we find the normal force? Well, firstly remember that if we have an object that is being pushed at an angle, then the normal force has to be equal to Fg plus F sine theta. Okay, that's what we must have basically. All right, So that's what we are going to basically use to calculate the normal force. But we know that FG actually stands for mg plus F sine theta. And our M in this case, guys, is going to be what? The mass of this object, which is 30. So that is the mass of the object. It's 30. And this G is going to be 9,8 plus this F, which F is this one. That F is this force here, the F applied at an angle. And so we will put it here to say it's 300. Then we have sine. What about this theta? This theta is 40 degrees. And our answer we'll get on our calculator. So on our calculator, this is what we're going to have. Excuse me, guys. On our calculator, we'll have 30 multiplied by 9,8 close bracket plus 300 sine 40, and the value we are getting here is 486,84. That's what we are getting. So our value is 486,84 newtons, and that's how you are supposed to find that vertical force, which is the normal force. All right, guys, that concludes this video. See you on the next one.